You know, in Java, one of the oldest statements we all learned just got a massive super-powered upgrade. Today, we're explaining the complete evolution of the humble switch statement.
So, let me ask you something. Be honest. Are you still writing your switch statements like it's 2004? With that endless cascade of colons and breaks? Because if you are seriously missing out on one of the biggest leaps forward in Java's expressiveness, and more importantly, its safety.
And really, this comparison right here, it captures the entire journey perfectly. We are going from that tangled, bug-prone switch on the left, the one that always felt a little bit fragile, to something clean, powerful, and just modern. So in this explainer, we're going to trace exactly how switch went from being a common source of headaches to one of Java's absolute sharpest tools.
All right, so let's start at the beginning. We've got to take a quick look back at the classic switch statement, right? The one every single Java developer learned on day one. And yeah, the one that came with a pretty nasty hidden trap.
And that trap, oh boy, was fall through. Forgetting a break? Come on, it was practically a rite of passage. We've all done it. And it would cause the code to just silently creep on down into the next case. This default behavior was, no joke, a notorious source of some of the most subtle, hard-to-find bugs you could imagine.
Thankfully, the folks designing the language knew this was a huge problem, and their first big evolution was aimed squarely at fixing this fall-through issue once and for all.
Okay, now look at this. The big deal here is the introduction of the arrow syntax, this little arrow symbol. It completely changes the game. It basically says, hey, if this case matches, you run only this code, and then you are done. It never, ever falls through. And as a really nice bonus, you can group multiple labels together with commas. Just look at how much cleaner and safer the code on the right is compared to that old mess on the left. But fixing the safety issue, that was just the beginning. The next leap, well, it was even bigger. The switch statement got a promotion. It became a switch expression.
I mean, think about it. What if a switch could do more than just run some code? What if it could actually give you a value back, like compute something and hand it to you? Well, that's exactly what a switch expression does. It lets you map an input to an output, and you can just assign that result straight to a variable, all in one super clean, readable block.
Now, this new power comes with a new rule, and honestly, it's a fantastic one: exhaustiveness. The Java compiler literally forces you to handle every single possible input value. What does that mean? It means no more of those, oops, I forgot a case bugs. You either cover every single possibility, or you have to add a default case. The compiler's got your back, for real.
Okay, so what if your logic for one case is a bit more complicated? Like you need more than just one line of code. That's where the yield keyword comes in. Just think of it like a return statement, but specifically for a case block. You just open up a block with curly braces, you do all your logic, and then you yield the final value you want to send back.
All right, we've covered safety. We've covered expressions. Now it's time for the main event, pattern matching. This right here is the single biggest upgrade. This is what transforms Switch from just a useful tool into a true language superpower.
Yeah, superpower unlocked. The core idea is that Switch can now act like a magnifying glass, or maybe even an X-ray, letting you look inside your objects. It's not just checking for simple values anymore. Now it can inspect the very type and the structure of your data. This is a huge deal.
So, first up, we've got type patterns. Just look at that example. Case string s. In one clean line, it does three things for you. It checks if the object is a string, it casts it to a string, and it binds it to a new variable s that you can use right away. While that old ugly if, object instance, string, boilerplate we used to write? Yeah, that's just gone. Good riddance.
But okay, what if just checking the type isn't enough? What if you need to be more specific? Well, that's where guarded patterns come in. By adding a when clause, you can tack on any Boolean condition you want to your case. So now you can ask not just, is this a string, but is this a string, and is it blank? It lets you build some incredibly expressive logic right inside your switch labels.
And if you're using Java records, oh, it gets even better with record patterns. This is basically deconstruction. It means instead of getting a point object and then having to call p.x and p.y to get the data out, you can just pull the x and y components out into their own variables right in the case label. You can start working with the data inside your objects immediately. So let's put it all together. Let's say you have a point record and you need to figure out which quadrant it's in. By using record patterns to grab x and y, and then guarded patterns with when to check their values, you can write code that reads almost exactly like this logic table right here. It's just so clean, so declarative, and incredibly easy to understand what's going on.
Okay, whoa, that was a lot of new power, I know. So for this last part, let's lock in all that knowledge. Let's do a quick rundown of the most important rules you absolutely have to remember to use this stuff correctly.
All right, let's do a quick fire round of these key rules. Rule 1, arrow cases. They never fall through, period. Rule 2, switch expressions have to be exhaustive, and don't worry, the compiler will yell at you if they're not. Rule 3, need to return a value from a multi-line block? Use yield. 4, and this one is super important, default does not cover null. You have to handle null with its own specific case null label. And finally, Rule 5, if you're using sealed types where the compiler knows every possible subclass, you often don't even need a default case. The compiler already knows you've covered everything.
Okay, now I can almost guarantee that as you start using pattern matching, you're going to run into this one specific compiler warning, dominated pattern. And you're going to think, what on earth does that even mean? It's actually pretty simple. It just means your case order is wrong. You have to think of it like a funnel. You have to put the most specific patterns at the top. So a case for a specific blank string has to come before a general case for any string. And a case for a string has to come before a case for just any old object. If you get that order wrong, the big general case will just swallow up the input first, and your more specific case will never even get a chance to run.
And there you have it. That's the complete evolution of Java's switch. It's gone from being this kind of flawed, clunky statement into a truly powerful, safe, and super expressive tool for modern programming. So that really only leaves one question, doesn't it? Now that your switch has superpowers, what's the first piece of old, complex, nested if-else code that you're going to go refactor?